Hi everyone, I'm Oindrila, a PhD student at UMass Amherst, and I'm here to present GANORCON, our generative models useful for few-shot segmentation. This work was done with Zezu and Subhranshu from UMass Amherst. We asked the following questions in this paper. Given a set of unlabeled images, how do we use them for learning in part segmentation tasks? And for this purpose, are generative models useful? One approach of using unlabeled images, like I said, is generative modeling. Given a set of unlabeled images, learn a model which mimics the distribution of the data. In previous literature, Fisher vector representations have been used to encode the distribution of local descriptors in images using Gaussian mixture models. This can then be used for discriminative tasks. In recent work, representations derived from GANs trained for image generation, such as StyleGAN, have been used to solve a downstream few-shot segmentation task. Generative adversarial networks are trained using a minimax objective where a generator network tries to mimic the data distribution while the discriminator tries to differentiate between real and fake. The other approach is to train a contrastive model. These methods learn by maximizing the similarity between the output features for various augmentations of the same image. The momentum contrast method, MoCo, uses the info-NCE loss to achieve this goal. Yet another contrastive learning approach, SimSciM, minimizes the cosine feature distance between two views of the same image. Unlike MoCo, this does not require negative examples to train. These are just two examples of contrastive learning based approaches. Now we come to the big question. Is contrastive modeling better than generative for few-shot part segmentation? We present a thorough comparison of each in terms of computational complexity, difficulty of obtaining labels, effectiveness of the method, and robustness. Now, how do we design a framework for few-shot segmentation which can harness unlabeled images? Let's go through it step by step. The first step is to train an encoder using any contrastive learning-based framework. For the backbone architecture, we use ResNet 50 in our case. For generative approach, this first step is replaced by training a StyleGAN-based decoder network. We then proceed to extract intermediate activation maps, referred to as hypercolumns, from the trained model in step 1. Then we use a relatively shallow network which we call the projector, which learns few-shot part segmentation using the extracted hypercolumns as input. This training happens using very few images, less than 50 typically. Now the projector network has two variations in our experiments, which is the MLP and the CON. For efficient inference, GAN methods need to create a dataset by sampling images and corresponding labels using the framework in steps 1 and 2, and then distill this dataset to an off-the-shelf feed-forward segmentation model. This is optional for our contrastive method as the model is feed-forward and inference is possible directly using step 1 and 2. For training and evaluation, we use the following datasets. We use flicker faces and Celibae mask for the unsupervised training dataset for the category of faces. For the downstream few-shot task, we use face34, which is a few-shot part segmentation data released by dataset GAD. We also use face8, which is a modified version of Celibae mask. For cars and cats, we use the corresponding LSUN images for unsupervised learning. For few-shot segmentation, we again use the datasets released by dataset GAD. We come to the final verdict. Contrastive models perform better, are simpler, much faster, and more robust than generative models. Here are a few illustrations showing how better our contrastive method performs. We describe each of these comparisons in detail in our paper. Recently, there have been swift advances in both generative and contrastive modeling methods. We now have generative methods such as StyleGAN 3 diffusion models. We have self-supervised vision transformers and object-aware contrastive methods competing from the con side. The GAN versus con competition is still on, and we plan to create a leaderboard to keep track. Watch out for more updates at this URL, or you can also scan the QR code. Thank you.